topic that attracted me more 40 years ago when I was a student. And I tried to tackle the problem with some knowledge in order to have to separate or distinguish between the torsional revision and lateral buckling. We have 4 parts: introduction. The second is by moment, that is an unusual internal force. You can use the equilibrium of equation in order to derive it, and then its effect. The third, we use the finite element method to create a model. And finally, we have some conclusion.
Mình chụp cái đó này, đây thì chụp luôn chưa?
You know that in urbanic region or city, there are many flyover or sky paths with the shaping curve. Those are horizontally curved structure. But this paper aimed at this structure but not bridge. So we use the horizontally curved box girder, not the horizontally curved bridge. Many prior students study about this structure, about these topics. From 1889, from the theory of St. Bernard torsion, 1885, up to 1961 from Glasgow for teamwork structure. And now, many study about it. Turn it out into the design technology, for example. So we aim at the teamwork structure subjected to torsion. But for the steel box girder, you know that these structures are made of steel, for example, or pre-stressed concrete. So the problem here is what is we can detect or identify the by moment. By moment as the unusual of the seventh component of internal force. We use the structure like this with multi-cell box girder, and we calculate the radius or the central angle with respect to the last span 90 meter of land. So we want to say that assumed theory to be verified is the effects, warping and torsion. You know that in a structure, even a stretch curve or stretch structure having subjected to the eccentric, not concentric loading, it causes torsion or twisting bending moment. Twisting moment. So we decompose it into 2 parts: pure torsion and distortion warping. The first is pure torsion. We can use the classical theory to identify the segment. And the second is the distortion warping. In turn, the second component it have 2 parts. That is the warping, and the second is the bending in transverse direction. Very interesting. But the problem here is the angle of rotation is not constant in the axial direction. That is the problem. It causes many normal stress and axial deformation. So we use making use of some theory about the torsion for teamwork structure in order to mention about the by moment. By moment can cause the axial stress sigma d omega. We can use the sectorial coordinate meter square, and this axial stress can be combined with some other component of axial stress due to the bending moment in lateral in vertical direction. In normal stress, we have some the equation. We focus on this with the distortion warping, and omega is called the warping function. We can have many private studies about equation for determining the eye moment along the longitudinal coordinate. So, but we can't see it easily or visualize this eye moment and its effect. So we try to use the finite model. We conduct some static analysis and dynamic analysis for this in order to find out some, some specific characteristic in order to distinguish it with lateral buckling that you know, or torsional lateral buckling. So we use the straightforward for the pilot structure, and we conduct 3 models of curved girder, 1, 2, or 3 cells. So we aim to calculate the eye moment at corner of the cross section in the transversal profile and along the span. In dynamic analysis, we concentrate on the first mode of vibration. So this is some result about the mind analysis. So we tabulated model A is rather or slight curve. More curve is model B, and the most curve is model C. We straight and we have some cells above it. The last 2 columns are the eye moment and warping distortion normal stress. And we come to some realize that the smaller curvature, the higher mode of frequency. But what is the direction of vibration? We often understand that the easiest direction is in vertical. But with some restraint, the direction of vibration is mainly lateral. We did not believe it at once, but I checked it with some calculate on the modal mass participation. In this, we can see that in the first frequency, the UX, that is the percentage of mass participating in motion in the lateral. And then we have some torsional, that is the percentage more than 60% and 60%. Then the lateral vibration is confirmed. But I think that it depends on the restraint, and the lateral stiffness is not enough. These are some results about the first mode frequency, calculated from the SAP 2000 software. The more curvature and the smaller first frequency. But in straight structure, when we come to with more cell, the frequency is low. It's very spectacular. And more cell, the longer period of vibration, but in lateral direction. So about the warping angle, chi EX along the axial coordinate, and the warping due to the distortion along the longitudinal direction. This formula from the prior knowledge, and we make use it in order to create our planned warping function. So we come to the realization that there are two parts: in-plane distortion and the out-plane warping. So we come to some preliminary conclusion like this. The first, we have two parts of torsion: the pure torsion and the warping distortion torsion. They are combined with the bending internal forces. And when we say that the restant torsion, it means that it depends on the structural rigidity, both in torsion and in flexural action. It depends on the cross section, for example, the number of cells, and especially in the restant. So, by moment, we say as the unusual internal force, but we can calculate it from another parameter or variable, and take into account the material stiffness and the section, for example, the moment of inertia or torsional constant. Torsional constant or stiffness in bending lateral or in the vertical direction. And finally, we focus on the restraints, fixed or bracing system. All of these can contribute to the restraint torsion. As for the dynamic analysis, the first frequency of model decrease as the curvature increase, and the frequency for a straight structure is smaller than that of the fewer distortion mode. Fewer distortion mode, that means the smaller number of cells. Thank you very much. And here are references. I use it for this paper. Thank you very much for your listening. Thank you. Is there any question?
Thank you very much, Professor Danton. Are there any questions? We just have a little time, just a couple, maybe one, two questions, because we have to finish at 12:30 for lunch. Thank you. It's really very interesting, and you've shown us how important it is to consider all the parameters when calculating. And it's not easy. It's a nice work. I think it should be continued, of course. Do you have any experimental results?
Thank you for your advice. The most willing ambition is to conduct some experiment. I prepare the Tabuchi method in order to design the experiment, but I have no fun for it. So sorry. But I will conduct my numerical method in order to some visual experiment.
Yeah, maybe you have some partners who can do it.
You
can decide.
advice.
Thank you. I give you the certificate.
Đây em chụp hình cho thầy.